compatible with 802.11b devices. It's also compatible with 802.11 devices. Realize that while communicating with a standard 802.11 device, it will slow down to 1 megabit or 2 megabit for its data rate. And that's the only way it can be compatible with these different modulation types. We also have 3 other major organizations that need to be identified to finalize our discussion on organizations and standards. The Wi-Fi Alliance, who promotes and tests for wireless LAN interoperability of 802.11a devices and 802.11b devices. Their mission is to certify interoperability of Wi-Fi products. Now, this is actually a trademark term now because of the Wi-Fi Alliance's work. When a product meets the interoperability standards and requirements as described in their test matrix, the Wi-Fi Alliance will grant the product a certification of interoperability, which allows the vendor to use the logo and advertising on all of their packaging and be able to have their product become fully certified. The Wi-Fi seal of approval is designed to assure the end user of complete interoperability with all other wireless LAN devices that also bear the Wi-Fi logo. Now, there are a couple of things about Wi-Fi's interoperability. One of them is only the use of 40-bit WEP keys. The Wi-Fi Alliance does not guarantee any interoperability checks beyond what's known as the 40-bit WEP key. Now, one thing to realize is that a 40-bit WEP key and a 64-bit WEP key are exactly the same thing. A 40-bit WEP key is actually, the secret component is concatenated with a 24-bit initialization vector, which actually makes it 64 bits. And that's where the 64-bit key comes from. This is quite a bit different than the 128-bit key, which is actually a 104-bit secret, concatenated with the 24-bit initialization vector. And that's what makes it a 128. Wi-Fi Alliance does not support 128-bit keys for interoperability at all. So you cannot guarantee that you will have compliancy between multiple devices that bear the seal if you're going to be using a 128-bit system. We also have what is known as the European Telecommunications Standards Institute, or ETSI. ETSI is chartered with product communication standards for Europe in almost exactly the same way that the IEEE focuses on the United States. The standards that ETSI has established, like HyperLAN 2, for example, directly compete against standards that have been created by the IEEE, such as 802.11a. Been much discussion in the past about IEEE and ETSI unifying on certain technologies, but at this time, nothing has really happened that has come forth that actually brings these two groups together. But the collaboration of these two group standards has been known as 5UP or 5UP, which stands for the 5 gigahertz Unified Protocol. The IEEE is actually attempting to interoperate with ETSI's HyperLAN 2 with a forthcoming standard known as 802.11h. So we'll see what happens in the future, but as of this time, this is not fully materialized. The original HyperLAN standard for wireless, actually dubbed the HyperLAN 1 by ETSI, was approximately 24 megabits per second using the same DSSS technologies that we're used to, and it went about 150 feet. HyperLAN 2, which is very similar to 802.11a, actually supports rates of 54 megabits and uses all 3 of the UNII bands, very much like the IEEE 802.11a standard does. So ETSI standards and IEEE standards are very much the same. The last standards organization that you need to know about is what's called the Wireless LAN Association, or WLANA. The Wireless LAN Association's mission is really for education and consumer awareness regarding the use and availability of wireless LANs and really to promote the overall wireless LAN environments in general. The Wireless LAN Association is really an educational resource if you're seeking to learn more about wireless LANs. They've got excellent information about a lot of the things that we deal with in this series that can take you even deeper into some of these components. The Wireless LAN Association does have quite a few partners throughout the industry. They do contribute content to the Directory of Information, all public domain, and actually some of the content that exists in this particular series was part of the Wireless LAN Association's publications. All of this is non-copyrighted information that's considered public domain. Great information for training your users on the availability, and even more importantly today is what types of things to look out for from a security standpoint when you're using wireless networks. Things like software firewalls and personal security, even physical security that users are going to have to worry about when they're dealing with a wireless LAN, especially when they have wireless access points at home. Anytime you get into a technology which is advancing as fast as wireless is, you're always going to have competing technologies which will surface as well. And there are 4 separate competing technologies that you really have to look at that directly compare and compete with our wireless LANs. Home RF, or home radio frequency, Bluetooth, which you may use now for peripheral devices on your computer, infrared, which is used quite a bit to connect printers and other peripheral devices to your PC, and finally open air. These 4 standards actually really resemble very closely the 802.11 family of standards. What they do, though, is are really more focused on fixing or addressing a particular business need. Home RF, for instance, operates in the 2.4 gigahertz band, but uses frequency hopping technology. Home RF devices only hop about 50 hops per second, about 5 to 20 times faster than most 802.11 compliant devices that use frequency hopping. So it is a little bit different, and they use what's called wideband frequency rules that have been set forth by the FCC. And this is not to say that IEEE is not going to support what Home RF does. It's just that currently it's not aware of the Home RF components and really making it part of the 802.11 series of standards. They use separate protocols like the SWAP protocol, Shared Wireless Access Protocol, which is a combination of CSMA and TDMA, things that are used in LANs and in cellular telephones. Really a hybrid of 802.11 standards that allows this type of technology to exist. Bluetooth, on the other hand, is another frequency hopping technology that operates in the 2.4 gigahertz band as well, although it's about 1,600 hops per second, which is incredible, and it has considerably more overhead than all 802.11 compliant frequency hopping systems. This gives the technology much greater resistance to narrowband noise and interference and makes it perfect for connecting peripheral devices to a PC. Mice these days, we even see some of our new data cell phones actually have Bluetooth headsets now. We don't have to be wired to our phone to be able to use the headset to be able to communicate on our cell phone. So this technology continues to advance and continue to be very popular as well. We also look at the infrared, which has been around for a while. The IRDA standard, or serial infrared, is really a light-based transmission technology, not at all spread spectrum, and does not use radio frequency radiation at all. This is purely a light-based standard, and typically only maxes out at about 115 kilobits per second, which makes it really good for exchanging data between a couple of PDAs, or makes it really good for exchanging data between a PC and a printer, but doesn't really make it viable as a network connection. And finally, Open Air Standard was created by the Wireless LAN Interoperability Forum. They're no longer in existence at all, and all of their website links have been pulled from the internet. So this standard was really something that was designed to create compliancy and alternatives to 802.11, and it really specified only 2 different speeds, 800 kilobits per second and 1.6 megabits per second. It's now kind of off the face of the planet as everything has kind of passed it by, as that technology was never improved upon beyond the 1.6. So now no systems that are interoperable with 802.11 are interoperable with open air. That standard is pretty much defunct at this time. And that should give you a pretty good idea of what standards organizations exist out there, and also show you why they're important. Not only from a fee standpoint, if we have a violation, but also understanding compliancy and compatibility. It's great that our standards organizations and standards bodies are actually taking some of our emerging technologies and really setting forth standards. It makes our life so much easier when we're trying to implement a functional and cost-effective wireless LAN. Without these standards, we would have to buy everything from the same vendor, and that's definitely not a cost-effective solution in most areas. So understanding these organizations, understanding the standards, and being able to align your hardware purchases and your wireless LAN specifications around what they set forth is an excellent idea. So, we've got all our frequency. Radio frequency, 2.4 gigahertz, 5 gigahertz. We've talked about UNII. We understand the ISM bands. We know all about the 802.11 standard. We got everything hooked up, and now life is good, right? Well, kinda. What about our clients? How do they locate their access point? What do they use? How do we know exactly that a client can even find an access point? We've dealt with all of this radio frequency. Not saying we're shifting gears here, but there are certain things that are part of the 802.11 standard which allow clients to locate their access point and allow the access point to reply. If a client is unable to find their access point, obviously they're not going to get